Have you ever wondered what everything is made of? Look around you, your chair, your desk, the air you breathe, even you. It's all made of tiny, tiny things called atoms. Atoms are like the super small building blocks for everything in the entire universe. Isn't that amazing? They are the fundamental pieces that come together to form every substance we can see and touch, and even those we cannot. From the biggest stars and distant galaxies to the smallest grain of sand on a beach, atoms are there, doing their important work of making up matter. They are truly the unsung heroes of existence. For a very long time, smart people thought atoms were the smallest things possible. They imagined them as tiny, solid balls that couldn't be broken down any further. The word atom even comes from an ancient Greek word meaning uncuttable or indivisible. It was a good idea for its time, based on what could be observed. But guess what? Science is all about discovery, and scientists discovered something super exciting. Atoms are not so simple after all. They actually have even smaller parts inside them, making them much more complex and fascinating than anyone initially guessed. So, atoms are not just tiny, solid dots like little marbles. Instead, think of an atom as a miniature, bustling solar system, full of activity. It has a very specific structure, with different parts doing different things. Understanding this internal structure is the key to unlocking so many secrets about how matter behaves. It helps us understand why some things are hard, like a diamond, and others are soft, like a pillow. It explains why some things conduct electricity and others don't. This hidden world within the atom is where the real magic of chemistry and physics happens, dictating the properties of everything. Exploring atoms is like going on an incredible adventure into an unseen world. These particles are so incredibly small that we can't see them with our eyes, not even with most ordinary microscopes. Scientists have had to develop very special tools and clever experiments to learn about what's inside. It's a journey that has taken many years and involved many brilliant minds. And guess what? The journey isn't over. We are still learning new things about atoms all the time. Each discovery helps us piece together the grand puzzle of the universe. At the very center of every atom, there's a part called the nucleus. The nucleus is super tiny, much smaller than the whole atom, but it's also very dense. This means it packs a lot of stuff into a very small space. Think of it like the sun in our solar system. It's the core around which other things move. The nucleus is where most of the atom's mass, or its stuff, is located. It's a busy place, home to two important types of particles. We're going to learn all about them. It's quite an amazing feat of nature how much is packed into such an infinitesimally small region. One of the important particles living in the nucleus is called a proton. Protons are super important because they have a positive electrical charge. Think of it like the plus sign on a battery. The number of protons in an atom's nucleus is what makes an atom unique. For example, an atom with 1 proton is always a hydrogen atom. An atom with 6 protons is always a carbon atom. So, protons define what element an atom is. They are like the atom's identity card, telling us exactly what kind of material we are dealing with. They also play a crucial role in holding the atom together. Alongside the protons in the nucleus, there's another type of particle called a neutron. Neutrons are interesting because they don't have any electrical charge. They are neutral, just like their name suggests. So, they don't have a plus or a minus charge. Neutrons are about the same size and mass as protons. While they don't define what element an atom is, they are still very important. They help to hold the nucleus together, especially in larger atoms where many positively charged protons are trying to push each other apart. They add mass to the atom and can affect its stability. Now, zooming out from the nucleus, we find another crucial particle, the electron. Electrons are much smaller and lighter than protons or neutrons. They have a negative electrical charge, the opposite of protons. Think of the minus sign on a battery. Electrons don't sit still, they whiz around the nucleus at incredible speeds. They are found in an area called the electron cloud, which takes up most of the atom's volume. It's because of electrons that atoms can bond together to make molecules, forming all the amazing substances we see. They are the atom's busy bees interacting with other atoms. You might be thinking, wow, protons, neutrons, and electrons are tiny. And you'd be right, but guess what? The story doesn't stop there. Scientists have discovered that even protons and neutrons are made of even smaller particles. How cool is that? These even tinier particles are called quarks. So when we thought we had reached the fundamental building blocks, nature surprised us with another layer of complexity. It's like opening a set of nesting dolls, there's always something smaller inside. This discovery really changed how we understand the very fabric of matter. There are 6 different flavors or types of quarks. Scientists have given them fun names: up, down, charm, strange, top and bottom. That's quite a collection of names, isn't it? Protons and neutrons, the particles in the atom's nucleus, are mostly made up of the 2 simplest types, up quarks and down quarks. For example, a proton is made of 2 up quarks and 1 down quark. A neutron is made of 1 up quark and 2 down quarks. These combinations give them their specific properties like their electrical charge and mass. The other quark flavors form more exotic, short-lived particles. An interesting thing about quarks is that they are never, ever found alone. They are like super social particles that always need to be in a group. They are always bound together, forming composite particles called hadrons. Protons and neutrons are the most common examples of hadrons. This phenomenon is called quark confinement. The force that holds quarks together is incredibly strong, one of the fundamental forces of nature. It's so strong that if you try to pull 2 quarks apart, the energy required actually creates new quarks, forming new pairs rather than isolating one. So what holds these quarks together so tightly inside protons and neutrons? And what holds protons and neutrons together in the nucleus? It's all thanks to something called the strong nuclear force. This force is mediated by particles called gluons, which are a type of virtual particle. Virtual particles are a fascinating part of the quantum world. They pop in and out of existence very quickly, carrying forces between other particles. They are like tiny messengers, constantly zipping back and forth, ensuring that the fundamental forces operate and keep matter stable. The quantum realm is truly a weird and wonderful place. Learning about atoms, from protons and electrons all the way down to quarks, is an ongoing adventure. Scientists are always asking new questions and performing new experiments. There are still so many mysteries to uncover about these fundamental particles and the forces that govern them. What else might be out there? Are there even smaller particles? How do all the forces fit together? This constant exploration is what makes science so exciting. It's a process of continuous discovery, pushing the boundaries of our knowledge about the universe and our place within it. Each answer often leads to even more intriguing questions. Understanding atoms is incredibly important for so many reasons. It's the foundation of chemistry, helping us understand how different substances react and form new materials. It's crucial for physics, explaining everything from the behavior of stars to the workings of lasers and semiconductors. This knowledge allows us to develop new technologies like medical imaging techniques, think MRIs, new types of batteries for our gadgets, and materials that are stronger, lighter, or have amazing new properties. Without understanding atoms, much of modern science and technology simply wouldn't exist. It impacts our daily lives in countless ways. The more we learn about the atomic and subatomic world, the better we can understand the universe on a grand scale. For example, understanding nuclear reactions within atoms helps us understand how stars shine, and how elements were formed after the Big Bang. It also helps us explore new sources of energy like nuclear power, which could be vital for our future. The study of these tiny particles has huge implications, connecting the smallest scales imaginable to the largest structures in the cosmos. It's a beautiful interplay between the micro and the macro. So the next time you look at anything, a tree, a glass of water, or even your own hand, remember that you're looking at a collection of trillions upon trillions of tiny atoms, each a complex world in itself. Knowing that everything is made of these amazing, intricate structures, with particles like quarks and electrons buzzing around, can really change how you see the world. It fills you with a sense of wonder and appreciation for the incredible complexity and elegance of the universe. It's a reminder that there's always more to learn and discover, and that's a truly exciting thought.